All right, so today we are to polynomials and the fundamental theorem of algebra. So the rational root theorem we've already discussed. This is taking all of the factors of the constant, dividing them by all the factors of the leading coefficient. That list of numbers, positive, negative, contains all of the possible rational roots. But as we know, we don't always get all rational roots. If we go back to this example that we did at the beginning of class today, right? Look at our answers. Our three answers at the bottom. We had -6, that's rational, but is that? No, that is not a rational answer, okay? So the rational root theorem is great because it gives me a list of all the possible numbers to get any rational roots, but there can be irrational roots. There can also be imaginary roots like we just had in that one, okay? So the irrational root theorem. If a plus the square root of b is one of your roots, it will automatically have what we call its conjugate as another 0. All right, so I know this one's not irrational, but just because I have it up. See how this always comes together? It's always some number plus minus I. Same thing would happen with square roots. I would always have some number plus minus the other square root. They're called conjugate pairs, okay? So they always come together in a pair. Yep.
Question, if they always come together, then why is, like, if that's not a rational one, then why does it have plus minus then?
Because this is that's what this theorem is saying. If you have an imaginary answer, it always has its pair that comes with it. But that doesn't work for the rational ones. They don't come in pairs, right? They just come, they can come as many as they want. 1, 2, they come separately. The imaginary and the irrational numbers will always come as pairs because I always have this plus minus. Does that make sense? Are you following me? Okay, so the irrational root theorem just says that they come in pairs. The imaginary root theorem just says that they come in pairs. Okay, so let's just take a second. If I told you that 2 plus the square root of 3 was one of my zeros, what would another one be? If it comes in pairs, 2 minus root 3 automatically is another 0 of that polynomial. Automatically. They always come in pairs, these ones. And you're just changing the sign in the middle. So let's try another one. What if I said -5 plus I was a 0? If you're only going to change the sign in the middle, its pair, its conjugate pair, which would also be a 0, would be -5 minus I. They always come in pairs. They always come together. So we can use that fact to kind of help us figure out what's going to happen with our zeros, okay? So the fundamental theorem of algebra, I'll run through that real quick, even though it's really kind of important. It just says if a polynomial has a degree of 1 or higher and it has complex coefficients, then it has at least one complex root. The corollary is actually what's really important, and we've been talking about this for a few days now. The degree of a polynomial is the same as the total number of solutions. So when you look at this example down at the bottom, you guys for days have been telling me how many solutions it has, which is 4, because that's the degree. That's the number of total solutions. Some of them could be rational, some of them could be imaginary, or they could be irrational. I don't know which is which yet, but here's how this works. I know there's going to be 4 total solutions, right? Now, if the imaginaries and the irrationals come in pairs, right? So I'm going to have 4 total. Let's see if I can get all of this on here. 4 total solutions. If I don't have any pairs of irrational or imaginary roots, how many rational roots would there be? 4, right? All 4 would be rational roots. So let's say possibilities for number of rational roots. So, I do write this down here below, but anyway, I'll just write it again. So, possibilities for the number of rational roots. If I don't have any pairs of imaginary or irrational, that means all 4 of those solutions are going to be rational. what happens if I have one pair of either imaginary or irrational? How many rational solutions would there be? Just two, right? Because the pair would take up two answers, so there'd be two left. What if I had two pairs of imaginary or irrational? Well, how many would be left here? Wouldn't there be none left? If I had two pairs of imaginary or irrational, that counts for four answers, right? Two pairs? That would be all four answers. So this gives me an idea of how many, remember that big list of numbers that we find by taking the factors of the end number and the factors of the beginning number, plus minus? Remember that whole big list? Right? So this kind of gives you an idea of how many of those could be zeros. You're never going to have three of them be rational. It's either going to be all four, just two of them, or none of them. Does that kind of make sense? Okay, let's try another example. If we look at, I gave you another sheet that says, where's mine? Of course I left it over there. Where's this at? Here it is. Okay, take a look at this sheet. So our instructions here are to state the number of complex roots. That's just the total number of roots. That's always the same as the degree, okay? And then the possible number of real roots for each equation, okay? Then factor each. All right, so in number one, how many total solutions are there? 4, right? So the possible real roots if I had no pairs of the imaginary or irrationals, how many, this should be rational. How many rational roots would I have? Four, yes. If I had one pair that was imaginary or irrational, how many would be left to be rational? 2. And if I had two pairs, what would be left? None. It always just drops by 2. That's it. So I take the total possible and then I drop by 2, and that gets me all the combinations that I could have. So if you look at the second one, how many total are there? 3, right? Because it's degree 3. So my possible number of rational roots could be what and what?
3 and 1.
3 and 1. Yes. I should be 3 or 1. Yeah. I'm either going to have 3 rational roots or I'm only going to have 1. And then my other pair would be imaginary or irrational. Okay? Now, one of the most important parts, though, is understanding the fact that all of their pairs are automatically 0. So jump down to numbers 9 and 10. Look at number 9. Well, actually, go back to 7. Do you remember how to do these? If I tell you what the zeros are, how to give me the polynomial? Right. If my answer was -5, what factor did it come from? X plus 5. Okay? If 5 was a 0, I got x minus 5, and 3 would be x minus 3, and then you just multiply these 3 together, right? That's old news. We did that a few sections ago. But now, if you look at number 9, one of my zeros is irrational. So even though I'm not going to put it in the list, you're automatically going to add its pair to the list. Negative square root of 5. Automatically, because they always come in pairs. So you can't have one irrational answer without its pair. They automatically come in. So now, watch how this works. -3, what did that come from? X plus 3. What do you think the square root of 5 came from? Well, you're going to do the same thing like you did here. It would just be same thing. X minus root 5. That's it. And then same thing with this one. It's going to be x plus square root of 5. All right. Now, helpful hint, when you go to FOIL all this together, be smart. These two you should multiply together first. Because watch what's going to happen. There's some magic. So if I just FOIL these two together first, okay? Let me zoom in a little bit. First, x squared. Outsides plus square root of 5x, right? Insides minus square root of 5x. Oh, how nice. And then, ladies and gentlemen, what is negative square root of 5 times positive square root of 5?
5.
Negative 5.
Oh,
Yeah, because remember, when you have a square root and you multiply them against each other, it just cancels itself out. So, but since it's a negative times a positive, I have a minus 5. So now, look what happens. These cancel out. That's pretty much always going to happen. So now I'm just going to drop down the x plus 3 from before, and now I have x squared minus 5. And now I can just FOIL those two together, but all of those square roots are gone. So don't multiply these two together first. You can, but you're going to make your life so much harder. Just multiply the two that match together. Things cancel out, your life is so much easier, and now I'm just going to FOIL these two. So if I FOIL those two together, I get x to the third first, outsides minus 5x, insides plus 3x squared, and then the last minus 15. And then all I have to do is combine like terms if I have any, but I don't. But I do have to rewrite that in standard form. So I just rewrite it, x to the third plus 3x squared minus 5x minus 15. And there's, oh, thanks. There's my answer. Okay, so the new little bit that you have to remember is anytime you have an imaginary or an irrational number, you automatically have to put its pair in as well. When you're solving, you don't have to think about it because the pairs always just come up, right? It just does it automatically. You don't have to be thinking about it, but you do have to be thinking about it with these, where I'm giving you the zeros, but I only give you one of the pair. So, if 3 plus the square root of 10 is a 0, what else is? 3 minus the square root of 10. Oops. 3 minus the square root of 10. Now, this is a little bit trickier because watch what happens. X minus 4, where did that come from? X plus 4. Now, this is a little bit weirder because you need to subtract a binomial. So here's how it goes. I want to do x minus all of this. So it really came from x minus 3 minus root 10. Because I have to subtract this whole thing, right? It's weird, but that's how those go. So, what do you think this came from? Ooh, you're so close. But I want to minus everybody. So it's still going to be x minus 3, but now it's a plus root 10. Oops. So one of them is x plus 4. The other one is x minus 3 minus root 10. And then this one I kind of messed up here, but it's x minus 3 plus root 10. All right, so that's the hardest part to remember, is you got to subtract both of them because you want to subtract that whole binomial. Now, when I multiply this together, multiply these two together because they're the ones that match, and then I'll worry about that. These are annoying, I get it, because now you have a 3 by 3. Ugh, but we know how to do this, so it's not so bad. So I'm going to multiply these two together first. I'll worry about the x plus 4 in a minute. So I'll do x times everybody in here. X squared minus 3x plus x root 10. Now I'll do negative 3 times everybody in here. Minus 3x plus 9 minus 3 root 10. Oh. And now I'll do negative square root of 10 times all of this. Minus x square root 10 plus 3 square root of 10. And what's negative square root of 10 times positive square root of 10? Negative 10. So now, yes, I have this big long line. How many numbers should be in this big long line before I add them together? If I had a 3 by a 3, I should have 9. So just before you combine like terms, just check that you have 9 to just double check that you didn't skip over anybody. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, good. Now I'm going to combine like terms. So hopefully a bunch of these things cancel out. Let's see. I have a plus x root 10 and minus x root 10. Good. I have a minus 3 root 10 and a plus 3 root 10. Ooh, good. Did you see that? So all my square roots cancel each other out. That makes my life way easier. And now I'll just combine what I have left. X squared minus 3x is a minus 6x. And then a plus 9 minus 10 is a minus 1.
Wait.
Yeah.
Oh, yeah.
But I'm not quite done yet because I haven't multiplied by the x plus 4 yet. So I know these are annoying, but they're totally doable. They're just tedious. So now I just multiply these two together. But at least I don't have any of those weird square roots anymore. They all canceled out. So now I just do the 2 by the 3, and we're good at that. So I'll just do that real quick. And combine like terms, and I will have my final answer. Ta-da! We should have a stick of y equals in front of that. And there it is. So, this is old news. It's just you have to remember to add the conjugate pair. All right? On the back, I just want to show you how to handle these where it says find all zeros, one factor has been given. Guys, they're giving you one of the answers. They're saying, hey, in this crazy thing, that's an answer. So it's them just giving you a little head start. It's the exact same stuff as this, but instead of me having to keep guessing numbers, they gave me one to start with. They just gave it to me, so I don't have to guess. So if x minus 2, they're telling me that's a factor. So what 0 is that?
2.
2. So if I plug in 2,
For x's?
what?
Can't you just like plug in the issue for all x's?
Well, no, because I want to do synthetic division because I need those numbers as my coefficients for the next one. That's what this is saying. So when they tell me that x minus 2 was a factor, that means positive 2 is a 0. So what I'm going to do is I'm going to drop down my coefficients. And when I plug in a positive 2, they told me it's going to work, so it better. So if it didn't, either I messed up or they lied. So I should get 1 as a remainder. So let's just go through this. Oh, yay! Yep. Can I do it after I finish this one? Okay. So now, guys, I did get 0 as a remainder. Good. So I have one of my zeros. What I don't have is all the other ones. So look at what's left, though. Remember how this works. That's the remainder, so I don't have to worry about that. That's a number by itself. X to the first, x squared, x to the third. So I now have this new thing I've got. I don't have enough room to do it on this paper, but here's my new equation, right? That came down, and I had the x minus 2. Now I have this thing, and I'm going to try and factor this just like you did here. Now it's like I'm starting you off with this, because now I'm not giving you a hint anymore. Now I'm like, okay, now find the rest on your own. So now I'm looking at this, try and factor by grouping. You can't on this one. So now you would do the factors of this divided by the coefficients and go through this whole process again to end up getting your zeros at the end. Basically, you have to keep going till what's left in here is a quadratic. You can only have x squared because those are the ones I know how to solve. If it's x to the third or fourth or fifth or sixth or seventh, I have to keep plugging things in until I find those zeros. Okay? All right.